October02 was this thing called a biconditional statement. A biconditional statement. Yes, that's all it is. A biconditional statement. Guys, come on, let's go. A biconditional statement is a conditional statement, Noah. If, then, or cause, effect, any one of those statements that is true going forward and backwards. A biconditional statement is a conditional statement that is true for P implies Q and Q implies P. And I'll give you a really, really easy example. Yeah.
Last week, it was on the homework list, you have, like, you just collected, usually you'll ask if you have questions, but it was like, it was like x equals 2 if 3x plus 10 is 16. But I didn't know how to write it. Like,
Oh, you just write out if x equals 2, then 3x. That's all it is.
oh, okay.
That's all
I
it would
didn't
be.
know.
That's all it would have been, yeah. Some of those things are quite literally that straightforward. So let me show you a really, really easy example of this. If an angle measures 90 degrees, then it is a right angle. You guys agree on that? If an angle measures 90 degrees, then it is a right angle. If I say that the converse, basically saying it backwards. If an angle is a right angle, then it measures 90 degrees. And that's also true. So it's true going in either direction. So going the other way would have been if an angle is a right angle, move this up then the angle measures 90 degrees. If it's the same, if it's true statement going forward and backwards, you call it a biconditional statement. That means we can rewrite it in the term called if and only if, otherwise known as if. If and only if. This is called an if. Yes, sir.
What's the opposite?
Then it's a right angle. If an angle measures 90 degrees, then it is a right angle. If it's a right angle, if an angle is a right angle, then it measures 90 degrees. I'm just saying it forward and backwards. So instead of writing out the word if and only if, because that's too many, in math we call it if, I-F-F. We abbreviate everything. We use symbols for everything. We write out I-F-F. That's just what it means for if and only if. Okay? So this statement could have said, an angle measures 90 degrees if and only if it is a right angle. It means the same thing going both ways. An angle, turn it off. And that's what that would look like. That's what a biconditional statement does. If it's the same going forward and backwards, you can write it with that good old I-F-F in there. That's it. An angle is acute if and only if it measures less than 90 degrees. An angle is obtuse if and only if it measures more than 90 degrees. You see these biconditional statements a lot of times with definitions. Two lines are perpendicular to one another if and only if they have opposite reciprocal slopes. If two lines have opposite reciprocal slopes, then they intersect. They're perpendicular to one another. Most geometry terms, anything that we can define, that's a real definition in geometry, we can rewrite it usually as that if and only if statement. That's why I wanted to show you that. You see it a lot with definitions. We'll see it a lot more as we start doing more of these style proof stuff that we're going to look at, which utilizes definitions and theorems all the time. So you'll see it a lot. Okay? I just wanted to briefly talk about that. Man? It's not that. So the other part then today is to start talking about with what's called the law of syllogism, and then we're going to talk about what's called the law of detachment. You already know this. You already know this because you do this every single day without even realizing you do this every single day.
Say that word.
Syllogism. It's also known as the transitive property because you've seen that in math. Okay. Now, what the law of syllogism says is basically this. Steve is taller than Mary. Mary is taller than Joe. Therefore, Steve is
Taller than Joe.
that's the law of syllogism.
Oh.
So it's like a line segment.
Seriously, that's basically what this means is this. If bless you. If it's another way of looking at it is this. If A equals B and B equals C, what can you say? A equals C. And the reason that this happens is that there's this diagonal component as you write things out. When we get to conditional statements and we start writing things out with this law of syllogism, Steve is taller than Mary. Mary is taller than Joe. If you start to write that out long form, Steve is taller than Mary. Mary is taller than. Notice how I finished talking about Mary, and then I started talking about Mary in the second one. That intermediate part is repeated right away as we go through it. What's up?
No,
So can you say like Steve is smaller than Mary, but Mary is taller than Joe? There would be no way to figure out if Steve's taller than Joe.
If Steve was shorter than Mary?
No, like if it says like Steve is shorter than Mary and Mary is taller than Joe, how would you know if Steve and Joe is the same?
You're right. Then you would have no conclusion. If there's something like that, then it's not to say that it could come up with it, but there's no way of knowing without more information. Right. Yeah. So guys, when we're looking at this, what we call law of syllogism, otherwise it's also known as the transitive property. We'll talk about this whole transitive property a little bit more tomorrow with the algebra, but it is very, very smooth. It's you're taller than somebody, they're taller than somebody else. That means you're taller than them. Okay. It's got that diagonal component as you read through it. Now, I'll show you as we get into this, the differences when you're reading statements, what it'll look like from this law of syllogism versus what we call the law of detachment. Oop. Let's skip it. Law of detachment is different. Law of detachment is different from the syllogism in such a way that it is very choppy. Syllogism kind of moved, it kind of flowed through. Taller, taller, you're taller than somebody else. Detachment, like you say, it's detached, it's broken up a little bit. And instead of writing out the total long form of the definition, which is kind of dumb, it's easy to walk you through an example again, because I think the examples are much easier to figure out. If I talk about detachment, let's say I do this. If it is Sunday, I will go to the farmer's market. That's just a regular old boring conditional statement. If it's Sunday, then I go to the farmer's market. Just like we started out. That's how these start out. Now what happens is you get the next statement. It is Sunday. So what are you going to say? I'm going to the farmer's market.
Does that have to go under it?
Usually that's how people write it. It doesn't have to. Basically what happens with this law of detachment, you're going to be given some generic start out, and then they automatically will say your hypothesis part is true. If it is Sunday, I will go to the farmer's market. Well, it's Sunday. Where am I going? That's all it is. Detachment breaks it up. Okay? Detachment breaks it up a little bit. Yes, sir.
So it's just taking the diff in the then statement and just putting under it.
That's all it is. It really is. And it's, you assume, when they define this stuff out, it's so unbelievably wordy for when all you have to do is what you said. So all you're doing is taking your if then statement and breaking it to that. That's, instead of saying if, they're just saying it is. They're making it a definite. They're saying that the if part happened. They're assuming that that first part came true, therefore the second part has to come true. That's all it is. That's all that is. Okay? Let me show you a couple examples here real quick. If the electrical power is off, then the refrigerator does not run. If the refrigerator does not run, the food will spoil. What are you going to say in the end? Yes, sir.
The electrical power is off. The food will spoil.
Good. Was that syllogism or detachment? Syllogism. Now, remember, the reason that it's syllogism is that, notice, this part is basically repeated. If it was detachment, it would have said, the power is off.
Oh, it's like just telling you the truth.
Yeah.
All right.
If it was detachment, it would say, the power is off. Oh no, the power is off!
No, it's not. Yeah.
Battery powered.
Generator.
Maybe he has unlimited data.
What's that? This is syllogism. Remember, the syllogism stuff, it goes, you're always going to have a double if-then statement. And what happened, the conclusion of the first one is the hypothesis of the second one. So if you think of it in terms of P implies Q, then that's going to imply something else, which means that's the whole idea of A equals B, B equals C, A equals C. Because this part is repeated. It's repeated along that diagonal. If it's not on that diagonal, it's not this detachment. It's not this syllogism. It's a weird thing to have to kind of explain to you guys in the geometry class about sentence structure and how things are written a lot of times. But if we get these ideas and some of these concepts down, as you start to talk about your own logic and proof stuff later on, it's going to be a lot easier to work through it. So that's why we're spending out here. Let's try and oh, sorry, we're still right. Yes, sir. What's that? Go to the bathroom. Yeah. So let me pull up another one here real quick. It's easier to use this. And like I said, we'll just talk through a couple of these examples. Don't have to write this out. If you just want to listen to what we're saying, that's perfectly fine. Now, a lot of times how these things are going to be worded, it'll give you this example of determine if the third statement follows 1 and 2 by, is it detachment, is it syllogism, and then if it doesn't follow anything, you can just say it's not valid. So if we go back to the detachment thing, if it's Sunday, I'm going to go to this farmer's market. Today's Tuesday.
The refrigerator's gonna be off.
The refrigerator's going to be off, exactly. There's nothing you can say about it. It's invalid. All right? I'm just, yes, you're right, it is Monday.
It's an example.
If an angle, let's go back and try this again. If an angle measures more than 90 degrees, then it is not acute. Angle ABC is 120 degrees. ABC is not acute. Is that true or false? It's true, so it's a valid argument, but is that a syllogism statement or is that a detachment statement? It's detachment. See how it's choppy? An angle measures more than 90, then it is not acute. ABC equals 120, which means it's more than 90. Therefore, it's not acute. That's what a detachment statement would look like.
So would you, so for this, you would say,
No, I'm done. This is, you don't have to come up with this statement. They're giving you all 3 statements. And you just, if this wasn't here, what would you say? According to this. If an angle measures more than 90, then it is not acute. ABC is 120. According to the statement, then, it means it is not acute. That's all.
okay.
Look at it again. All 45-degree angles are congruent. Angle A is congruent to angle B. Angle A and B are 45-degree angles. Is that true or false?
True.
It's false. It's false, because does this say that angles A and B are 45 degrees?
No.
They could be 42 degrees. Okay? That's the idea here. Doesn't necessarily mean that it happens. It's the idea of getting through this. What's the other one I had on here? So the other part then, it's actually going to be easier if you guys have your Chromebook open. That way you don't have to try to draw all this. I want you guys to go to the website, and I want to pull up, and I'll show you, remind you guys how to get to that. I want you guys to pull up this worksheet so that way you can kind of read through what we're doing as well. Because the second part of today's stuff is in section 2.4. So remember, obviously we start, what chapter do you think we are in now?
2.
Good. So I'm thinking we would click on the chapter 2 tab.
I still click on 1 for the text. Only
How's
because
homecoming,
at first
Mr.
it wasn't
Murphy?
there, so it was like I had it.
What I want you guys to do is scroll down to where it says 2.4 practice B, please. That way everybody, and if you don't have your Chromebook, sit next to somebody that does. And I want to look at this. And I want to look and talk through, could you get the door phone, please? And I want to look at the second page of this, where it has this diagram that looks like that. Okay? All right. Go ahead and pull that up so we can take a look at it, guys. Yep, you got it. That way.
Yep, we got it.
You guys got it? Okay. So what I want to do here is kind of the secondary part of, well, the part in 2.4 talks about postulates and diagrams and all that other junk. It's not in the book, it's the worksheet. Okay? What happens a lot of times that we need to pay closer attention to is how do we infer information from diagrams? And that's kind of what they talk about a lot in 2.4. It's so we use we use a lot of our definitions and things like that from chapter 1 into these pictures. So let's take a look at this and kind of go through it together. Because being able to draw and come up with valid diagrams is really, really, really important in back half of this school year. All right. So, oops. So what I want to look at here is, can I answer a couple of questions from the diagram? Okay. In this case here, do I know for certain that points A, B, D, and J are coplanar? Well, remember, what is coplanar again? What's coplanar again?
Not the same line.
I thought they were in the
Coplanar.
same line.
On the same line.
Same plane. Coplanar would be same plane. Collinear would be same line. Okay. So again, guys, a lot of this is going to go back to your definitions and things like that from chapter 1 that you kind of have to remember. So our points A, B, D, and J all in that same plane.
Yes.
Everybody okay with that?
Yeah.
Now, if you look at it, what this diagram really looks like, it's just the intersection of two pieces of paper, really.
False.
So I'm looking at it. I'm actually looking at this picture. That's what this looks like right now, guys. That's what that is. That's all that is. Okay? That's all that is. The intersection of two sheets of paper. That's it. All right?
Wait, let me you do that.
How did I do that? I just cut the paper.
Well, I can't see it. Did you like tape it together or something?
No.
You cut it and then slide it up.
I didn't know that's what you did. Well, I see
You're
it.
like really amazed by this, so now you
No,
Merry Christmas.
Thanks. Well, I just I didn't know how you did it because it looks pretty cool.
Anyway, so our points A, B, D, and J coplanar. Is that something you can infer from the diagram? Yeah. Because it's a true statement. Okay. Now, can we infer that angle angle EDA is a right angle?
False.
Why?
Because there's no box.
Perfect. There's no little square box in there. When you have right angles in diagrams, you're going to have one of two things. First of all, it might actually state that the angle is a right angle. Or secondly, it'll have that little right angle box in it.
Would it be a lowercase r? I've seen it.
I've never seen that before. All
My
right.
computer wasn't did. I was.
Our points E, G, and A collinear.
Yes.
E, G, and A.
You're not on the same line as
No.
Also not on the same line.
They're not on the same plane either.
Yeah.
Point E is on the plane K.
Yeah.
G and A, well, A is shared between them, but G's on the other plane. They're on different planes. They're not going to be there. Okay?
Listen, boys.
Can we say that FG is perpendicular to plane H?
No.
Why?
Because it doesn't.
Yeah, I can.
But it doesn't. I mean, it's inside of plane H, but it's not like crossing anywhere. I don't see. I mean, it crosses at point C, but that's not.
You're on the right track. Guys, notice. No, a line can go across the plane. Let's see it really fast. Plane, right? There's a line. That line, what is it, FG? Coming through here. It's just in the plane. It's in the plane. It's not perpendicular to the plane, it's just lying within it. It's one of the blue sheets, blue lines on your piece of paper, if you think of it that way. It's not perpendicular. It just says it's false. Plus, if it was perpendicular, you would see a right angle. Do you see any right angles?
No.
No. Okay. Are angles ABD and angles EBC, are those vertical angles?
Yeah. Yes. Wait. ABD. Oh, wait.
Are angles ABD and angle
Oh, yeah.
EB?
They're vertical angles. True.
Are those two?
Oh, yes, they are.
Now, are those both angles in the same plane?
No.
Yeah.
Yeah.
Wait, yeah. Hold up, they're all shared.
Oh, yeah, they're all on K.
They're all on K, yes, because the angle, the K plane is the more lighter colored one. It's in the front here, it's in the back there. You're going to be using the idea of vertical angles out of a diagram a lot. A lot. We use this all the time. When we get to triangle proofs, when we get into things like that, finding vertical angles is one of the very first inferences that you're going to be able to make, because it's a very simple thing to look for. Okay? It's a very simple thing to look for. Next. Planes H and K intersect at line AB. Is that true or false?
True.
Both.
Planes H and K intersect at line AB. True or false?
True. I think it's true.
False.
Why is it false?
Yes.
Is
Is after like.
Because what? How many points do you need for a line?
Two.
So is it true or false? It's true.
I said true.
It's true, guys. It's true. Guys, remember from the other day when you guys had to write out on the test in chapter 1 about the whole how do you write equations line or what lines and things like that? One of the things that you had to do was list or write another name for a line. Lines need 2 letters, ladies and gentlemen. They don't need any more than that. That's all they need is 2 letters. Now, think of that, the intersection of 2 planes. The intersection of 2 planes here always creates a line. Ceiling is a plane, front wall is a plane, isn't it? When you look at it that way, that crease there would be the line. That's like your line AB. It's things like that. You don't need to have 3 letters for lines. You will never have 3 letters for lines. Okay. Do lines FG and lines DE intersect one another? FG and DE. It's false, guys. Relook at it. Relook at it.
They're on different planes.
They're on different planes. Guys, they're on different planes. Isaiah, can I have my awesome picture again? Do you mind?
I passed it around.
Oh.
It's somewhere.
Remember, guys, when you're drawing these things out, thank you. These two lines will not intersect one another because they're in different planes. What are those lines called? Lines that don't intersect that are in different planes. It was a vocabulary term, like, can you have congruent lines? Let's think about it.
Perpendicular.
Let's just stop throwing things out there and maybe looking at our notes where we can find out what those things are called. Well, we've only done 2 chapters, and I'm saying, remember when we did this. What chapter do you think I might be referencing?
Chapter 1.
2.
3.
Logic.
Is it a triangle?
9.
Isosceles.
Parallel.
No. 2 lines. How about we stop yelling right now? Okay? You guys really need to remember, one of the, if not one of the most important things in geometry is that the vocabulary and the terms that we learn one day they come back each time. If this is something you had forgotten, ladies and gentlemen, you really need to go back and relook at all your vocab in chapter 1 because we're going to use it a lot. Okay? They're called skew. Skew lines. Two lines that are not in the same plane that will not intersect. We wrote that down. We probably did the example of the ceiling line. Just pick out one of these little the tracks for the ceiling tile,
And the floor.
and then the floor tile.
Oh, yeah, we did talk about that.
If you look at this grout line right here going left and right, and that ceiling line going forward and backward, they're never going to intersect one another because they're in two different planes. They're not parallel, they're called skew. Yes, sir? Lines on the paper are parallel because they're on the same plane.
Wait, so does that mean 19's false too? Because it's on the same plane?
It says an angle GCA and angle CBD are congruent. That's false because they're in different planes. I mean, it's possible they could measure the same, but we don't have anything that says that they are. If they had tick marks, even if they're in different planes, could they be congruent?
Yep.
Yeah, because a 47-degree angle is a 47-degree angle. Even if they're in different planes, it's still going to measure 47 degrees. Okay, but that's what we look at. Now, the other part that I want to talk about is at the very bottom of that sheet. The very bottom of the sheet has these directions. And this is another thing that we would start to work on more and more with, is how can we build our own diagram from given information. Okay? So what we need to do is we're going to take a couple minutes here and we're going to create a map. We're going to create this map. Now, what's the first thing you have to have on a map so you know where you're going?
A legend.
A legend, a compass, a key, whatever you want to call it. Now, when we put the compass in there, that's this. What's up top? What's over there? Then what?
South.
Then what?
West.
Never eat soggy waffles. Okay?
Never eat sour
So, what I want to do is we're going to draw what this looks like. So the first thing it says is that building B is due south of A. When something is due south, due east, due north, what does that mean?
That direction.
Well, you ever heard, what is, if I want to say, if I say Chicago is due east of here,
It's east.
it's east, it's directly east.
Oh,
When you say due south, it means it is exactly right behind you.
So it's like not like west, south.
Right, it's not, if I say southwest,
So Sycamore is
Sycamore is not due, Sycamore is more northeast of here. This would be northeast. This would be southeast, southwest, northwest. Okay? That's why they talk of it in terms like that. Yes, sir? No. Hey, this is a good question, though. What if you say something is east, northeast, it means it's more this way than it is that way. Yeah. You get into bearings and stuff like that. We do nautical and airplane bearings trigonometry problems in pre-calc, and we talk about directionality again later on. So if I say building A is building B is due south of building A, where would I put A?
Right above.
Above B, like that?
Yes.
Okay. And then it says next, buildings A and B are on street number 1. So I just make a street. And I label it street number 1. Okay. Building C is due east of building B. So on what side of B do you put building C?
on the right side.
On the right side, good. it says that B and C are on street number 2. And I label it. D is southeast, so what direction is that going to be?
It's on the left, but it's wrong.
Look again.
I mean, oh, no, wait.
Go southeast.
Southeast is this way.
Yeah, so it's on the right.
And then it said, what, street number 3? Oops. I should have gone through the middle. All right, so there's street 3. Now, the last thing it says is that building E is due west of C. Yes, ma'am.
Well, I have like a spice.
What's that?
Can I tell you
Yeah.
that we're west? Like right there.
What, the E? Now, could I put, you're saying I could put E here, but couldn't I also put it here?
Yep.
Hey, gotcha.
Mr. Fagan, it doesn't, it's not a gotcha.
Oh.
Are you even writing this down?
No,
Oh, I gotcha. See?
you did get me there.
So what happens is, it doesn't tell you specifically, all it says is it's west of it. So it could be placed either spot until we read the next bit of information. The next bit of information says angle DBE. The angle that's formed is either going to be DBE or DBE is a Q. So where is E placed? Is it here or here?
It's in between.
It's in between. You're using that process of elimination, you're using the deductive reasoning to put it all together. It's kind of the same thing like we worked on Friday, we did all those, the grid things. You knew this, you knew this, you knew that. It's the same kind of idea, okay? Who had something over here? So now you can, if you read those last questions that are on there then, you have all the information that you can do that. Draw a diagram. You did. It's beautiful.
It is.
Where do streets 1 and 2 intersect?
And B.
At B, right. What kind of angle is formed at street 1 and 2?
All right.
Why do we know that?
Because.
It is.
But
Straight.
there's not the.
But there is no square
But why do we know that it's a right angle?
because it meets in the midpoint.
This was, no, there's no, is there anything in an angle talk about midpoint?
No.
Will you ever have midpoints and angles together?
No.
The
No.
middle, the vertex.
No.
Stop just throwing words out there, okay? What do we know about A and B?
That they are
South. Due south. Hold it here, I'll give you that. We know it's due south. If C was due east, what kind of angle is formed when you have south and then you turn to the east?
right angle.
It's a right angle. So yes, that has to be a right angle because of the way that maps are made. Okay? If you ever looked at a street grid, street grids are all parallel and perpendicular lines. That's how they draw them up. That way you don't get lost.
Okay, so E.
If you look at, which one was it? Find it here. I mean, seriously, if you guys just look at, would one of you guys grab the lights for me real fast? When do you guys get the lights real fast, please?
I got it, Mr. Murphy.
Look at just the street, the road maps of DeKalb. All these. Thank you. If you look at the road maps of DeKalb, you have parallel lines. 7, 8, 9, 10. Those are all parallel to one another. Okay, they're all parallel to each other. Each one of these intersections is a right angle. Okay, you do that same thing if you get when you get out to what's
Exactly.
when you get into New York. If you go into where is it? As you start to, when you start to get into here, just look at the grid work Just look at the grid work. Everything's a parallel or perpendicular line. They go by numbers. Every street has a number. You have streets and avenues. Everything in New York is either a street or an avenue. So as you're going through, you know that all the streets are going one direction. All the avenues go the other direction. So if you know that you have to go to 110th Street and 50th Avenue, you would just have to look at the two streets, which way you're going up or down, to know whether you're going uptown or downtown. And then you just kind of go and you walk to the intersection spot. That's what that does. That's how grid work was done for roads. That's how they do, that's why they have these things. Otherwise, I mean, it's more prevalent in cities or in older parts of towns, because when people first moved there, that's what they knew to do. As you get into subdivisions and stuff like that, then you get the long winding curves and cul-de-sacs and all that. But more often than not, when you get to the central parts of towns, you've got grid work. Downtown Sycamore is all grid work. Yes, sir.
So it's like in the crowd, like you can basically like locate where everything is because of Drop 38.
Kind of, yeah. Yeah. And if you look, even think about Malta, in the little downtown area of Malta, right off of 38 there. All those streets are parallel to one another or perpendicular to one another. There's no winding road through that neighborhood because that was the original part of town, and that's how they did subdivision. That's how they parceled out land, by parallel to perpendicular streets. That's how these things work. It's the easiest way to set up stuff. Okay. So. Yes. So what I want you guys to do tonight is I have two sets of problems. In section 2.3, it's on page 90. Guys, cut it out. In 2.4, I want you to do those. Now, the first grouping of problems here, and I'll pull it up here in a second, talks about syllogism and detachment. And they want you to come up with the statement at the end. So if you think about the example that I gave you guys a little while ago about the farmer's market, if it is Sunday, I'll go to the farmer's market. It's Sunday. What are you going to say?
I'm going to
I'm going to the farmer's market, okay? That's what that means. If you give me a sec, I'll pull that up and I'll walk you through one of them. So, like I said, bless you.
Thank you.
If I'm looking at that first question, if I use the law of detachment with this first statement, if the measure of an angle is 90 degrees, then it is a right angle. The measure of angle A is 90. What are you going to say?
It's a right angle.
What is?
The angle. I mean, wait. The right angle.
Which angle?
Angle A.
Angle A is a right angle. That's what you say. That's it. Your answer is angle A is a right angle. That's all.
That's a bell. It's only a left.
See you guys. The bells are off again. I think of the times and whatnot. Someone get the lights on the way out, please.